So let's have a look at the cloth settings. Let's turn that on, turn everything else off. So just play that through. So we get a cloth. I might just rewind that and do that. Boink. So one of the things about this new cloth solver in the NPM, it is apparently a lot more robust. It was a little bit dodgy to begin with, but these newer versions of it, apparently it does really good fast interactions and stuff like that. And the other big selling point of this is it does tearing. We can tear it, which is really cool. Let me do this. Let's go to attribute editor with that selected. I'm just going to give it some more resolution. Maybe 60, make that 40, maybe make that 80. Right. So just to sort of give it a bit more stuff to play around with, and let's bring this a bit over. So I'm just looking at our cloth settings. We can close that up. Right. It's a bit slower now because I've upped the resolution. There we go. Let's have a look at the settings then. So we have got density, it's quite high, 1500. Viscosity is set to 300 by default. Let's have a look what it says about that. How much motion nearby points will be averaged out kinetic meters per square per second. Let me put that down to 0. Hold on. It's just a bit more wibbly wobbly, isn't it? Sort of more. And obviously, one of the things to sort of say, which I've not said already, but all this again is scale related. MP settings, we've got the scale units. We're at a meter at the moment, so these are pretty big. This is like 5 meters big. It's like a massive big torus of air. Right, let's go back to here. So back to 300. Area preservation is degree in which the cloth will preserve the face area versus the face shape. This value is uniqueness. It should be between 1 and 1. 1 means no shape preservation, large areas, no area preservation. The most solid value in between. This is probably a bit like. This is the same as this. Where are we? Where is it? Not that one. Yeah, it's volume preservation, isn't it? It's the same thing. It's just called area preservation in this. So, I wonder what that will do. So, it's probably quite hard to tell. I mean, all these things are quite subtle, and they should sort of really interacting with them. Collision speed max. Vibration speed we've looked at, that's how stiff it is. Let's just try that at sort of 200. This will slow it down, I think. In fact, it's slowed it down quite a lot. You can see cranking that number up, it really does slow the simulation down. And it does warn you of that. Let's not bother with that because it will be here for hours. Go back to 30. Collision max speed. Is back to include volume, medium value should be positive. Large values give stiffer results, similar to vibration. Increase this if you're having trouble with interpenetrations. There we go. So I won't really see that here. Thickness, I can't remember what thickness was. Thickness is the thickness of the cloth in meters used together with the mass density area for setting the mass per point. Not sure we're going to see much with that if I change that. Friction, initial speed, direction, all those ones we know. Preserve volume, this will try to keep it, the shape of it, like a sort of balloon. Oh, that's not really doing it. It is actually. You can see it's slightly more balloony there. I'll zoom in a bit. You can see it's sort of. Let's select it. Just trying to keep a bit more of its initial volume. I think if you crank up that target volume, controls how much volume of the air inside as a ratio of the volume of the reference point position. The cloth will stretch outwards or sink inwards, trying to match a target volume. Only has an effect when the interior of these on, which it is. Let's put that at 20 and see what happens. Whoa, there you go, sort of balloony, exploding outwards. One of the things to be aware of in relation to NPM is it is like an aero simulation. It is voxel based, so when these things get bigger, they're going to make more voxels. They're going to take longer to sim. Let's just cancel that. So we're sort of getting a big balloony. Let's put it back to 1. So let's have a look at tearing. Let's just turn that off. Well, first of all, for it to tear, it has to be put on some sort of duress. And let's try and set that up. I've got my cloth mesh there. So we're going to do this by looking at also another attribute, which is constraints. So I'm just going to duplicate. No, actually, I'll just make a new one. New cube. Let's hide this for the time being. And so there we go. And let's make this 4 and give it 4. I don't know if we actually need a lot of these. Right, I'm going to put that one in there. I'm going to duplicate that one. I'm going to put that one there. And I'm going to animate this one. Get a frame 100. Move it over there. And I'm going to rotate it around 180. 18, 180. There we go. So let's rewind back. So back to the graph. Oops. So I'm just going to bring these two in. Cube 1, cube 2. And under my cloth properties, we are going to, actually I think it's source, isn't it? We need a constrain NPM, like that. So how you constrain it is, you can see here we've got this constrain, These an NPM source. These are the geometry that's going to be the constraints, and then we'll look at the properties afterwards. So what you need to do is you unplug that, you plug him into there. Let's just see if we can see these a bit better. So just make it a little bit more visually. So we've got that, and then we need to plug in the geometries, the two cubes which are here. Let's just move these down a bit. And these haven't been massively, these are newish, as in there wasn't constraints in the first version of Bifrost and the NPM. So they're pretty primitive in the sense that you really only have them on and off. So strength of 1, means they're going to constrain, and how they work is they constrain the objects which is inside them. So inside there now, these objects should be constrained to these little cubes, and we'll give that a test. Let's just look at the properties of this again. I just want to see strength. Strength of the economy, unconstrained, value of 1, 0. Yep, so 0 to 1. I think when it first came out, it was either 0 or 1, so it was either on or off. But now they've got some softness, so you can have a sort of spring-like. But let's just try this to see if it works. Let's hide our clothlish H. Right, go back to parameters, get rid of U, and let's hit play. Let's just put this to 100. So you can see they're constrained to it. And it's being pulled, stretched and deformed and twisted. And even though my sort of resolution is pretty small, you're getting pretty good interpenetration of them. So that's that. I might animate that a bit further along, and I might make it 360 as well. Actually, let's do a 720. Let's take it to the. There we go. Right. Get rid of that. So we've set this up just so we can demonstrate constraints and also demonstrate tearing. So let's just move this over. So I'm just going to play this out. What are we, 12 minutes? One more time. Which I probably should zoom out a bit. There we go. But as you can see already, I'm not tearing it yet, but I just wanted to sort of see if this would work. Oh, it's had a bit of a funny turn. Maybe because the resolution is quite low. But you can see up until that bit where it did have a funny turn, it was actually doing it pretty well. Now it's had a bit of a... It's got a bit weird there, probably because of the not massively high res. Anyway, but before I cooked it, it was twisting quite well. But we won't worry about that too much because I'm not demonstrating that at the moment. What I am demonstrating is tearing. So let's enable tearing, and the first things you've got to do is detailed failed triangles or subdivide and split. I've generally used subdivide and split. I think detailed failed triangles. Yeah, so it sort of deletes the bits, maybe. Well, we'll try both and see what happens. But I think the better of the two is this subdivide and split. And what you'll see is it meshes the whole geometry. So now, when we do play, we've got a tearing threshold. This might be enough to do it. Let's have a look. Weirdly, since I redid that, it's actually that twist is working now. It's gone now. There we go, and it's all. Oh, that's cool, isn't it? That's pretty sweet. And there we go. So, real tearing cloth in Maya now, which is pretty cool. And just to sort of demonstrate, I think the threshold is if you make it lower, is it lower? Maybe it's higher. Well, let's put it to 0.1 and see what happens. Yeah, so it tears immediately, look. And you get all these nice little teary bits that fall and stuff, so it's pretty cool. Well, that's sort of, getting some nice bits. Yeah, so that is the cloth tearing. Look at that, it's just, because it's so low, it's just literally disintegrating. Let's go down and have a look at it. But pretty quick, considering what it's doing, breaking all those up into little bits. Right, so that was cloth and tearing.